Hey guys, we're going to talk about predicting products and go through the examples today. All right, so for predicting products, if you know your reactants and type of chemical reaction, you can predict the products. We're going to follow these general forms, and I do have several examples here, but I'm not going to go through all of them with you. These slides are posted, so go through those on your own. But tips for predicting that are really important. You want to crisscross your charges and reduce if necessary. So for like zinc oxide, zinc is a +2, oxygen is a -2. When I crisscross, I get ZN2O2, which then reduces to ZNO. When writing lone elements, and I'll make sure I mention this again when we actually do the examples, you write just the element. You don't write numbers, you don't write a charge, unless it's a diatomic. And remember that your diatomics can be remembered with Brinkelhoff, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine, are all going to be their symbol and then the number 2. When we do a replacement reaction, positive ions can only switch with positive ions. So metals can only switch with metals. Cation polyatomics can only switch with cation polyatomics. And negative ions can only switch with negative ions. Remember, compounds are always written metal, non-metal. Never write them non-metal, metal. And then another thing is that HOH can be reduced to H2O, or you can write it as H2O. So let's go ahead and do some examples. So I have 7 examples here at the beginning that we'll go through, and then I have, I think, 4 more at the end. So this video is going to be a lot, and that's okay. We have a lot to go through. So the first one I have here is BAF. So I'm already told that this is a synthesis reaction. And I'm going to do a lot of like color coordination in hopes that this will help. So BA, we're going to focus on being blue, and F, we're going to focus on being red when I write this. So in a synthesis reaction, we have 2 things become one thing. So we know they're going to become something that's both of them together. So BA is a +2 on my periodic table. In F, and you notice that there is a 2 written with it because fluorine is a diatomic, but F on the periodic table is a -1. So I'm going to crisscross these. So when I crisscross them, they're going to become BA F, and then those numbers are going to go with them. So the 1 off fluorine is going to go to the barium, and the 2 off barium is going to go to the fluorine. So the final compound is actually going to be BAF2. So when I predict the products in this one, my answer would be barium plus fluorine is going to yield barium fluoride, and barium fluoride's formula just happens to be BAF2. So that's the first one we're going to go through. All right, our next one is a decomposition reaction. So decomposition is the opposite of a synthesis reaction. We're going to have one thing become the 2 separate things. So strontium and hydrogen here. So we're going to say strontium is red this time, and hydrogen we're going to make blue. And we're going to separate them. So strontium plus hydrogen. So they're becoming their 2 separate items. And when they separate, we're going to write our lone element as a lone element. And if it's a diatomic, it's going to get a 2 with it. So strontium is a metal, and it's not a diatomic. So when I write that one, it's just SR for strontium. Hydrogen, on the other hand, is a diatomic. So when I write hydrogen, it's just going to be H2. And I don't crisscross charges or anything on these because it's a decomposition reaction. It's just breaking into its individual elements. Now for this case on this one, it won't always be like this. You have strontium hydride, and it just happens to work out that you get SRH2 because strontium is a +2 and hydrogen is a -1. But it won't necessarily always break down like this. That just is a happy accident on this one. All right, for combustion reactions I think are the easiest for predicting products for the reason that their products are always CO2 and H2O. And to make up for that, combustion reactions are just that much harder to balance. Sorry about y'all. So the products on a combustion reaction is always going to be CO2 and H2O. So those make it the easiest to predict for that reason. All right, single replacement. In single replacement, your positive ion is going to switch with another positive ion, or in this case, we can go ahead and say a metal is going to switch with another metal. So these two guys are going to switch places. So let's go ahead and write that out. We're going to write out what that looks like. And that just means I'm going to have copper plus the nitrate over here, and we're going to have to balance, or not balance, we're going to have to crisscross our charges in just a second. And I'm going to have silver by itself. So let's look at silver first. So silver is a metal. It's not a diatomic, so we are just going to write it as Ag. Copper, on the other hand, we're going to crisscross to come up with the charges. So copper, it's copper 2, by the way. And if we were doing a problem on this, I would tell you that. So it's copper 2, so it's Cu plus 2. And nitrate is a -1. So we're going to go ahead and crisscross that. So that means this is going to become Cu, and then the nitrate goes in parentheses. And we're going to put a 2 on the outside because we crisscrossed. So your final answer would be this guy as your products. So copper 2 nitrate plus silver. And while we're not doing it right now, a way that you can check that you're predicting your products correctly is by balancing them. And if it balances correctly, or you're able to balance it, then that means that you have switched all your ions and all your charges correctly. But we're not doing that right now. We'll get to that later. Okay, another single replacement. So in this single replacement, I've actually written out the word formula, and we're going to come up with the formula and then switch it. So I have 10,2-phosphate reacts with lead. So 10 is SN, and it's 2. Phosphate is PO4 with a -3, and it's going to react, which means plus lead, which is just Pb. Because lead is by itself, we just write the formula. So we're going to crisscross this really quick to get our formula. So we have SN3 PO4 2 plus lead. So who's trading places in this situation? Well, I've got 2 metal ions, your tin and your lead, so they're going to be the ones that are going to switch places in this reaction. Phosphate's going to stay where he is. So that means my products are going to be lead, and it's also going to be lead 2 phosphate plus tin. And again, tin is a metal. It's not a diatomic, so I'm just writing it as is. And I'm going to go ahead and crisscross really quick. So we get Pb3 PO4 2. So this would be your products part. This up here was your reactants. All right, so now let's do some double replacements. All right, in this first double replacement, we have magnesium chloride with lithium carbonate. So we're going to crisscross, or we're going to switch them and then have to crisscross everything. So magnesium and lithium, we're just going to trade places with. We're going to leave the anion, non-metal, polyatomic part by itself. We're going to leave that where it is. So to come up with the answer to this, we're going to leave the Cl and the CO3 part by themselves. Carbonate has a -2, so I'm going to go ahead and write that in, and chlorine has a -1. And this first one is now with lithium. Lithium is a +1. And magnesium comes over here, and magnesium is a +2. And I'm going to plus between them because it's 2 ions. So now we're going to crisscross our charges. So I end up with LiCl plus magnesium is a +2, carbonate is a -2, so it just becomes MgCO3. So I could have said and put the 2's in and then have to get rid of them, but I'm just going to skip that step and just show you the final answer. All right. And then our next double replacement is another word problem. So it says copper 2 nitrate reacts with iron 3 carbonate. So copper 2 nitrate drawing a 3 is really hard to do. I don't know why. It won't let me draw one correctly. There we go. Okay. Reacts with iron 3 carbonate. There we go. And I think I said this is, I'm going to double check to make sure that's the right formula for carbonate. And that is. Okay, we're good. All right, so now I'm going to crisscross so I can get my actual formula that I'm starting with, get my reactants, correct reactants formula. So I end up with Cu NO3 2 plus Fe 2 CO3 3. Okay, so that's what I'm starting with. These are my reactants. So now I'm going to switch out my metal ions and come up with my products. So when I do that, I'm going to have to crisscross again. I know lots of crisscrossing. So I had iron 3 to begin with in the problem. So I'm going to have iron 3 in the nitrate ion plus copper 2 in the carbonate ion. Okay, so I'm going to crisscross here. So I get FeNO3 with a 3 on the outside plus, and I have a plus 2 minus 2, so it just becomes CuCO3. And that's going to be the products for this one. So this is the final products. Up here was my reactants. Here are my products for predicting products. Okay, so now we're going to predict products from just having reactants. So we don't actually know what type of reaction is taking place. What we know is what our reactants are. So the first thing you have to do is determine what type of chemical reaction you have. So generally you can say if you have an element and it's going to yield a compound, which means it's synthesis. Generally for a decomposition reaction, you're just going to have a compound and you'll end up with an element and an element. Combustion, again, you'll have some sort of hydrocarbon plus oxygen, and your products are always CO2 and H2O. To determine if it's a single replacement, you'll have an element plus a compound, and you're going to end up with an element and a compound. And a double replacement, you'll have a compound and a compound, and you'll end up with a compound and a compound. I know I'm just saying a lot of words, so let's just go for it. All right, so I have only 4 examples here. So let's go ahead and do these. And I think the one example I don't have is I don't have a combustion reaction. And the reason I didn't put a combustion reaction on here is because it would be something like carbon tetrahydride reacts with oxygen. And from that, you'd be able to say, oh, carbon tetrahydride is CH4, it reacts with oxygen, so it must be a combustion reaction. The products have to be CO2 and H2O. So that's the only one I didn't come up with an actual example on, but the rest of these, it's going to cover your other types. But first, we have to figure out what type of reaction is going on. So the first one says chlorine reacts with aluminum iodide. So let's go ahead and just write out what our reactants are, and then we'll figure out what type of reaction is. So chlorine is a diatomic, so it's Cl2, and it's going to react with, so plus aluminum iodide. Aluminum is Al, it's got a plus 3, and iodine is I, and it has a minus 1. So we're going to crisscross that really quick. So the formula is AlI3. So if you look, I have an element and a compound. So this is going to be a single replacement. So I have an element and a compound. I'm going to end up with an element and a compound. So in this case, my anions are going to switch places. So these two guys here are going to switch places. Lucky for us, chlorine is also a diatomic, or iodine is also a diatomic. So iodine is going to come out by itself, and because it's a diatomic, it becomes I2. Plus, now I have an aluminum with a plus 3, and I have a chlorine with a minus 1. So that's going to become AlCl3. So that's the products for that. All right, let's do the next one now. On this next one, I have sodium sulfate reacts with lithium bromide. So sodium sulfate. Sodium is Na+1. Oh, I accidentally skipped back. Hold on just a second, guys. There we go. All right. Sodium is a +1. Sulfate is SO4 with a -2. And it's reacting with lithium, which is Li+1, and bromide, which is Br -1. So we're going to do some crisscrossing real quick. Crisscross, 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 crisscross. All right, so my beginning formulas are Na2SO4 reacts with LiBr. So for this one, again, I'm going to switch. It's a double replacement. I should probably say that. I've got two compounds, so it's a double replacement. So in a double replacement, I'm going to switch two of my ions with each other. So I'm going to switch my two metal ions. So that's going to end up with, I have lithium +1 and sulfate -2. So I get Li2SO4 plus I have sodium in a +1 and bromine in a -1. So NaBr. All right. So the next one. All right, it's a sodium reacts with hydrogen. So sodium is just Na. It's not a diatomic, so I'm just writing itself. Reacts with hydrogen. Hydrogen is a diatomic, so it's H2. I have two reactants, two elements. So what I have here is a synthesis reaction. So in a synthesis reaction, I have two elements. I'm going to come up with one product. So what I'm going to end up doing is I'm going to go Na is my metal, hydrogen is my non-metal. So I end up with NaH. All right, and then let's go through our very last example. All right, on this very last example, I have potassium bromide decomposes. It decomposes. That means it's going to be decomposition. So potassium is K+1, bromine is Br -1. So I have KBr decomposes, and it's going to break down into its individual ions. So I have potassium, which is just a metal, so I write it by itself, and bromine, which is a diatomic, so it becomes Br2. And this was decomposition. All right, guys, I hope this really helps you out. Please message me if you have any questions. I will talk to you guys later. Bye.